Okay, let me share my screen. Let me know all of you are able to see my screen.
Yes, Parag, we are able to.
Yeah, thank you. So when you registered this course, welcome to this course. You would have download this zip file. Okay, please let me know if any one of you not able to download it. I will help you out. Okay, please let me know. Most of the people I um, I was able to download it, I guess. Some people send the request for increase the download limit. I did for few people, which they were facing a downloading issue. Okay, and so you would have downloaded this course underscore download.zip file. So this contains almost all the source code. Okay, and apart from that, you need to say for the environment setup. Okay, so either you can set up the environment by scratch. I'm going to explain you the steps. Okay, or there is a pre-built VM which you can download and import it on your machine. Okay, so if you are using a laptop to set up the environment. Okay, so you can extract the course underscore download.zip file, and once you extract, you will find a folder called course download, and inside that there is a folder called ecom real-time case study. Okay, so under this folder there are multiple subfolders. Just first we'll focus on the documents folder, and you will find one PDF where it's basically giving the overview of our use case project. And then you have to start from this file, which is a ecom underscore real time case underscore study underscore project setup underscore v1.txt. So once if you open this file, okay, so there is a prerequisite. Okay, so example, if you want to set up your project, the environment from scratch, you should have the Ubuntu 20.04 Linux operating system with login sudo user name as DataMaking. Okay, so if you want to just start from this installation, right, from installing Python followed by MySQL and other stuff, or if you want to set up the if you want to use the our this is one way, and another way is if you want to use the pre-built, as I mentioned earlier, you can just go and download the pre-built VM from this Google Drive. Okay, so if you open it in a browser, I will just minimize this. So you would have seen this DataMaking VM3-new.zip. Okay, this is the file which I downloaded. So this is the file which I downloaded, and if you extract this file, you will get a DataMaking VM3.ova file, which is the pre-built VM in the form of .ova file. It's a virtual machine image file. Okay, so this you can import, and directly you can use the user ID as password, and sorry, user name as DataMaking and password as DataMaking, and you can use this machine. So how to import this virtual machine on your laptop? I given you the steps in this video. Okay, so you can follow through the okay. Okay, so if you look at this playlist, you can actually import this. You can use this the part number 6, where it will help you to import the virtual machine image file into the Oracle VM VirtualBox software. Okay, so what you need to do is we need to install this software. Someone is new to the what is Oracle VM VirtualBox. It's basically a virtualization software where you can have host the another operating system on your existing operating system as a virtual machine, right? Which will help you to create a virtual machine and install a different operating system than what you have it in your uh, laptop or desktop. Okay, so you can import the whatever the virtual machine you downloaded. Anyone have any questions till now? Okay. Okay, I assume all of you are able to get it. Okay, now let's start from the installation of this. Okay, so one is Python. First, what you need to do is you need to install this Python machine on Ubuntu. As I mentioned, you need to have the Ubuntu operating system. So what you need to do is, for people who want to do from scratch, so they can go and create a virtual machine. Okay, this is the virtual machine that I created. Okay, and install the Ubuntu operating system with a username as DataMaking. If you want to do that, you can follow the same playlist from the line from the video number. So you can follow the part 5, which will help you to install the Oracle VirtualBox, and then you can come to the part number 7, which will create a virtual machine and install the Ubuntu operating system. The version I'm using is 20.04 LTS. Okay, and then followed by I created each video for installation. So I'm just going to walk through this step. But if you want to just to do it in the offline, you can go and watch these videos, which will help you to install the different runtime environments like Python, Java, Scala, and also components like Apache, Hadoop, Spark, and Kafka, which we are going to use it in this use case project. So before we start this, before I start explaining about these steps, I will walk you through the project, then we will come back here. Okay. So when you want to start working on
space will be used, sir, for all
sorry,
these installations? How much disk space is required, sir?
You need basically I would say see, generally for installing operating system, 10 GB is enough. But when you assign 10 GB, right, mostly the OS installation itself will consume all the space. So I would request at least 50 GB of disk space you can use it. If you want to have it, you can have at least 52, at least start with from 50s. But I would suggest 100 GB so that you can have some data if you want to analyze some data, right? So you can store it in, if you want to store some data which is there in local, then I would suggest you to have a 100 GB. So for me, initially, when I built this, the image file, which I shared with you all through Google Drive, I allocated 75 GB for this virtual machine. Okay, so till 75 GB, this virtual machine can accommodate. So in my local machine, yesterday for the installation steps, I started building this virtual machine from scratch. So I allocated 100 GB for it as a disk space. For memory, it's based on what is how much memory you have it in the laptop. So I would suggest if you have 8 GB of RAM in your machine, allocate 4 GB at least, so that your working with the virtual machine will be faster and smooth. Since I have a 12 GB of RAM in my laptop, so I allocated 6 GB.
Got it.
Yeah, thank you.
Hi Shiva.
Yeah.
So is there any alternate for because in my system I had only 4 GB RAM.
Okay. Okay.
So is
So
there any
You can use cloud. We have the free tiers in the cloud, so
yeah,
you can build.
so correct. So yeah, you can address my name as Pari. Okay, basically my full name is Pari Margu. You can address me as Pari. And yeah, as Magendra Red mentioned, if you don't have a local laptop with the sufficient RAM and disk space available, the next option I would suggest cloud. Okay, is you can use any cloud provider and create a virtual machine uh, with the so one is create a VM. Like example, take a, if you are familiar with the Amazon AWS cloud provider, so you can create a EC2 instance, okay, with the Ubuntu operating system, and you can start installing these components. Okay, that is one option. And otherwise, you can create a Windows VM and import this virtual machine also in the Windows VM in the cloud. So there are two options available. So based on your convenience, you can start using it. Okay, so there is a I have another YouTube channel. Okay, it is called yeah, it here on the left. So there is a YouTube channel called Spark FAQ, Spark frequently asked questions. Here I build that one playlist. Okay, where how can you create this single node, same whatever I did it on here, right? Whatever I did it on here, how to create a simple virtual machine here and install the Hadoop software. So this will be a one choice for you. So you can start using this. Okay, so people who don't have sufficient RAM on your laptop and disk space, you can use that. Does it answer your question? I will share this link also with the group so that you can start following it. Whatever the steps I used, it's very similar to this whatever the steps I given it in these files. In fact, I just modified whatever I used it here. Okay, so wherever said this, I would have used the Spark version 3.2 point something. Here we are installing Spark 3.3.0. So only minor difference in the steps is required here. And if you face any issues, I'm always there to help you. You can follow that. Any other question? Okay, so I assume I can proceed further. Okay, so what is the next thing we are going to do? I will just whatever PDF we have it here. Okay, so whatever PDF I just have it in a PPT, so I just open this. Okay, so sorry. So the building a real-time sales dashboard using Apache Spark and Kafka and Python Django. So basically, what I build is consider the okay. Consider there is a e-commerce portal. So it can be like a portal like Amazon.com, Amazon.com or Amazon.in. Right, or it can be in com, or you can take it as a Flipkart, any e-commerce portal, right? Okay, so in the e-commerce portal, whenever we order any product here, so what happens is there are different category of data is captured during the order you make on the portal. Okay, so one is inventory data. Like say example, when you buy some particular product, so the inventory has to be get reduced here, right? If you have inventory DB. Right, and then you might also have the payment gateway details, right? The payment details that will say payment details. Payment details. Apart from that, you will have one is basically a order DB or order details to capture the order details. Okay, there are like this kind of data is captured whenever you make a transaction or make an order in this portal. Okay, so one, we know why we are capturing inventory data. So basically, so whenever I have, say example, I have 10 products. So if one product is purchased, so I need to make the quantity as 9, and so it will go. And then once all the products are over, then it has to show out of stock, and then I have to bring it from the warehouse. So that is for tracking the product. We have to make the inventory DB and payment details. Whenever the customer makes the transaction, I need to make use of I need to store the payment details so that I can track that. Order details, like say, apart from product. Okay, so product details with the details are captured in order data. So using this data, we can do some kind of analysis. Say example, somebody is about the project, about the product. Okay, so whether he has bought the product with some other items. Okay, so then in the future, you can actually check with the other customers' order, and you can find some correlation. Okay, so there are a lot of analysis you can do based on the data you capture on this. Okay, so that is the main motive of this use case. Okay, so you can consider any e-commerce portal or online stores where the transaction happening. Okay, and how do you capture the data, and then how do you process the data? Okay, so that's our motive of this use case. Anyone have any questions? I call this entire data is the sales data. That's why I just kept real-time analysis of sales data. I'm sorry if my little throat problem. Just bear with me. Fine, fine. So I assume we can continue with next step. So I'll just make sure I have the recording going. Okay, fine. Yeah. So we have the sales data, right, or the order data. Now we want to do the analysis and find out some insights. There are two kind of analysis. One is, okay, we are storing the order details in a databases or any persistent storage. We can do the offline analysis. Means offline. When I say offline analysis, so you store the data in the late hours, maybe in the night, you can run a nightly jobs. They also call it as batch jobs, right? We can do either batch analysis where you capture the entire day data and run the analysis job or the reports job in the night and generate the report so that it is available for next day. Okay, so example, today is the 30th July. So you capture the 30th July record and process in the night and make the available data tomorrow. So that people can go and review the reports and find out, okay, what has happened yesterday on this e-commerce portal or the store. That is batch analysis or offline analysis, whatever the analysis you. And second is, okay, whenever the transaction is happening, then at the same time, right, in the real time, just bear with me, there is some vehicle is going on. I'm sorry for the background. So that is real-time processing. Okay, so as soon as the data is captured, we want to process the data. Okay, that is real-time analysis or stream processing, whatever terminology they use it. So we want to do the real-time analysis. So first we need to, okay. So this meeting will get over within 10 minutes. So as I mentioned, please use the same link and rejoin the meeting. Now what we need to do is, we need to capture this data, right? So we are going to so we have to capture this real-time data, okay, and either store it in database and process, or you can process in real time. Okay, so we are using Spark streaming here. Okay, so Spark is the Apache Spark is the one component of framework which will help you to do both batch processing analysis and stream processing analysis. So it's basically a computing framework or a kind of data processing engine or framework. So we are using Spark structure streaming. Mainly, we are using structure streaming. I hope everybody is having basic understanding of Spark. If people are anyone, if you are very new, so Spark is basically meant for building the solutions for batch processing and stream processing, and also we can do some kind of machine learning implementation also. Okay, so we want to why we are using Spark structure streaming. As soon as the data is generated in real time, we want to capture the data and store it in the any persistent storage and do processing. Or whenever you capture the data, capture the stream data and then do the processing. Do the processing on fly and then store the aggregated data in any persistent storage. Okay, so this is another way. Okay, so storing the data which is you capture in real time and storing in any persistent data, persistent medium. It can be a normal the distributed storage like SDFS, or any object storage like S3 in AWS, or a blob storage in Azure cloud, or Google storage in GCP. All of these are object storages you can store. So this process, capturing the data from any source and storing it in any persistent storage, called data ingestion. So there is a terminology called data ingestion. People will call in this data processing discipline. So data ingestion, nothing but you capture data from any data source and store it in a particular storage. So then take the data from the where you stored and do the processing. So generally that's data processing, right? So structure streaming can use both. So you can you can build a pipeline or a job which can do just data ingestion. Take the data from here and store it in particular DB or file storage, or capture the data and do the processing and store it in the database or any file storage. Okay, so that is the two things, right? Now before we are directly consuming the data or capturing the data from this sources, right? It can be any sensor which is generating data. So what we took is basically e-commerce data, right? You can think of as any sensor. It can be industrial sensor or the sensors which is available in your home, which emit the data in a certain interval. Okay, right? So those type of data also called as stream data. So any device which emits the data in low frequency, right? With the low latency, that's called stream data. So it can be a data generating from sensors, or it can be a data generating from any applications. You capture the data, okay? So you can directly capture, or generally what we do is we in between we use the layer called message layer. Messaging layer, right? So here we use any messaging system. So generally nowadays people have started using the distributed messaging system. Messaging system. So like Kafka. Okay, so in our case, we are going to use the messaging component as a Kafka. Okay, so we have 4 minutes, fine. So we are going to use as the Kafka as a distributed messaging system. So why we use? So basically, whenever we consume the data directly from that stream source, there might be a chance of your job, either data ingestion job or streaming job, can go down, right? There is a failure is always we cannot avoid it in certain cases. So that time you may lose the stream data, right? We don't want to use the stream data. That's the reason we are using messaging layer. The messaging layer going to act as some kind of buffer. So you store the data, you make data to be stored on this message layer. Then the streaming job can consume the data from this message layer. So basically, it is called a publish and subscribe mechanism. So if you learn about the definition of Kafka, they mentioned it is a distributed messaging system, act as or work in the discipline of publish and subscribe patient, right? So some system will be publishing the data on Kafka, which generally they call it as producers. So the terminology they call it as producer, right? Any application can act as a producer, then publish the data to Kafka. And any application can consume the data which is published in the Kafka topic. So all referred as a consumers, right? So you can have n number of consumers who can take the data from the Kafka. So Kafka is acting as a kind of message buffer or the middle layer, a middleware or whatever you call it. So in Kafka, we have multiple terminologies. I will introduce you when we look into the Kafka topic especially. Okay, so there are 5 things you need to understand in Kafka. One is a Kafka producer, which I told you, any application who produce the data to Kafka, they are called as producer. And Kafka broker or Kafka server, right? So again, Kafka is another library or framework which you configure in any machine. So Kafka also can be configured in a cluster of machines. So multiple Kafka servers can be configured to work as a cluster. So Kafka server is a server which will store your data. And there is a another terminology called Kafka topic. Topic is nothing but kind of container where it is going to store your data. Okay. So, and another terminology you need to understand is partition, right? So internally Kafka is partition into different segment. That means, so if we want to split the data into multiple, because we are using a distributed computing, which is a cluster of machine is there. So we want to store whenever you store the data in Kafka topic, we want to store it in a split the data into store it in multiple machine so that it can support the fault tolerance. And another terminology we want to understand is consumer. That is application which consume the data from the Kafka topic. Okay, so I will stop here. So there is only 1 minute left in this session. So please join the same link so that we will discuss next step. Okay. I hope that's okay for everyone. I'll just stop the session. Please join with the same link.
Yeah, sure.